Hello, ladies and gentlemen. Today we're going to be talking about surface area and volume of cones. We've already talked about pyramids, and cones are going to be very similar to pyramids because now cones just have a circular base versus a different kind of base that pyramids had. So it's like a special type of pyramid. Okay, so what you're going to need are your notes, a calculator, and a writing utensil, so a pen or a pencil. So just like how we started with pyramids, we're going to start with the parts of a cone. So feel free to write this down, but if you already know all of this stuff, then don't worry about writing it down. Okay, so for a cone, the base is going to be the circular bottom or the only flat side of this object. The vertex is now going to be the top point of the cone. So in a pyramid, we called it the apex, but for a cone, it's called the vertex because all of the other parts are smooth around it. And then the height is the same as a pyramid, so the perpendicular distance from the base to the vertex. And then the slant height is going to be the distance from the vertex to the circumference or the base's edge or the edge of that circle. So you can see in the picture the slant height is this distance versus the perpendicular height was the height of the cone. And then the lateral face, because there's only one, is one continuous curved side, or this thing that goes all the way around. Oh, that was kind of gross. I don't know why my pen does that sometimes. But the lateral face is if you've ever gotten like a waffle cone and it has like a wrapping paper around it or something, or any kind of ice cream cone that is, and they have like wrapping paper around it like this. If you unravel that wrapping paper on the cone, that's the lateral face that we're talking about. And because that is it's all smooth around that part of a cone, like all the way around here is smooth, there is actual no lateral edge because it's all technically a smooth surface. So that's the lateral face, or some people call it the lateral surface because there's only one in a cone. Whereas in the pyramids, we had multiple lateral faces, and those were all the triangles. Okay, so this first formula for surface area is going to be the area of the base plus the area of, so the area of the base obviously is going to be the area of a circle, so pi r squared, plus like the wrapping paper of an ice cream cone that goes all the way around the cone, which is pi r-L, where L is the slant height, and of course R is the radius of the circle. So make sure you get this formula written down. It's very specific. It's a little different than all the other because all the other surface areas we've ever done so far, we say, hey, you just add up all the sides together. But now for a cone, we actually have a specific formula, which is the area of the circle, plus pi r-L, which is this region. And remember, with surface area, sometimes it's easy to draw the netting. That's what this is called, for you to figure out what you need. So remember, if they give you, like in a couple problems, if they give you H, we're going to have to find this we're going to have to use that triangle to find L if they give you H and R. Okay. Let's look at some examples. So here's the first example. We have to find the surface area, and they gave me the radius is 5, so this is R. And then, like I said, they gave me the height, but I want to find L. So right away, let's do surface area is equal to pi r squared plus pi r-L. So the first thing we have to do is find L. So we have this triangle. I'm going to bring this triangle to life over here and pull it out of the cone. So this distance is 5 and this distance is 12, and we want to find what L is, or that slant height. So we're going to have to use Pythagorean theorem because we don't have any degree measures and we have two side lengths. So it's going to be 5 squared plus 12 squared is equal to L squared. Remember, the hypotenuse is always the C in this case, so it's going to be 25 plus 144 is equal to L squared. 25 plus 144 is 169. And then you're going to take the square root of that. And the square root of 169, I'm pretty sure is a perfect square. Yes, L is 13. So if you punch into your calculator the square root of 169, you get 13. So that's what L is. So my slant height is 13. So now we can plug in the surface area stuff. I do not know why my pen is making these funky motions, so I'm going to erase that. Okay, so we have pi, and then r is 5, so 5 squared is 25, plus pi times 5 times 13. So surface area is going to be 25 pi. For whatever reason, we always put numbers in front of pi, so I'll switch that around. And then 5 times 13 is 65 pi. And then 25 plus 65 is 90 pi. Or if you don't like keeping your answers in pi and you like decimals, it would be 282.7433, and it's all going to be centimeters squared. So either 90 pi or the decimal 282.7433 centimeters squared. Okay, example number 2. Now they want us to find the radius. Oh no, I'm sorry. They want you to find the surface area. But they didn't give you the radius, so we have to figure out the radius. So they told us that this angle, so if I pull out this triangle again, this right triangle, this angle right here is 54 degrees, and the slant height is L, which is going to be 15, and we have to find what R is. So we're going to have to use SOHCAHTOA. So remember, with SOHCAHTOA, you're going to pick a reference angle. This is the only angle we know, so we'll pick there, and we have a side that is adjacent to us, or touching, and we have the hypotenuse in this right triangle. So if we have the adjacent and the hypotenuse, we're going to be using the cosine, or adjacent and hypotenuse. So the cosine of 54 is going to be equal to the adjacent, which is R, all over the hypotenuse, which is 15. So what you're plugging into your calculator is 15 times the cosine of 54. Okay, so I got to plug that into my calculator. Sorry, just give me a second. 15 times the cosine of 54. You should get R is equal to 8.8168. Remember, we're rounding to 4 decimal places. And if you did not get this decimal, then you probably either punched it in wrong, or your calculator is in radians and you need it in degrees, because we're talking degrees here. Okay, so now we can find the surface area because we have the radius and we have the slant height. So it's going to be pi r squared plus pi r L. So surface area is going to be the 8.8168 squared times pi plus pi times 8.8168 times 15. Well, 8.8168 squared is roughly 77.7356 pi plus, and then 15 times the radius is 132.2517 pi. So then if you add those two together, you get 209.9873 pi. And so it doesn't really make sense in the world of mathematics if you have a crazy decimal times pi. So usually when that happens, instead of keeping it in exact form, we're going to convert the whole thing to a decimal. So if you type in your calculator 209.9873 times the button pi, or the pi button, you're going to get 659.6945, and that's all centimeters squared because we're still talking surface area. Okay, now the volume of a cone. So just like a pyramid, it's going to be the 1/3 times the area of the base times the height. So really, you could say for the volume of a cone that it's going to be 1/3 times pi r squared times the height. Because in a cone, the base is always going to be a circle. So remember that big B always represents the area of the base, no matter what formula you're in, and H obviously is the perpendicular height of the cone. Okay, I guess I had a little another animation there for you. So we have 2 examples for this guy. So now the first one, they give me the radius, so R is equal to 5, and they give me the slant height is 13. So volume, remember our formula is 1/3 times pi r squared times the height. Well, we currently don't have the height, so we're going to have to pop up that triangle again and redraw it. So we know that this distance is 5 and this one's 13, and this is h. So now we're going to have to use Pythagorean theorem because we don't have any degrees or angle measures. So we're going to, and we have 2 side lengths. So the hypotenuse is always c, and so in this case the hypotenuse is 13. So it's going to be 5 squared plus h squared is equal to 13 squared. 5 squared is 25 plus h squared. 13 squared is 169. We figured out number 1. So minus 25 from both sides, minus 25 from both sides. H squared is 144. In order to get h alone, we have to take the square root of both sides. H is 12. We should have known that and recognized that because we basically did the same thing on example number 1 for surface area. Okay, so now we have everything that we need. So it's going to be 1/3 times pi times the radius squared is going to be 25 times the height is 12. So we're going to take 25 times 12. 25 times 12 is 300, and then 1/3 of that, well, here I'll write it down. 1/3 pi times 300, but you can take 1/3 times 300, or 300 divided by 3 is 100 pi, which is a nice number, or you can give me 100 pi feet cubed, or you can give me the actual decimal, which would be 314, excuse me, 0.1593 feet cubed. So you can leave your answer in exact form, or you can give me the decimal. Okay, example number 2 for volume. So now we need to solve for x given the volume of the cone. So the volume is 216 pi inches cubed, and x represents the radius of my base of this cone. So volume, remember our formula, is 1/3 times pi r squared times height. And so we're going to replace everything we know in this picture in the formula. So we know that V stands for 216 pi, and that's going to be equal to 1/3 times pi r squared. We don't know what r is, so actually let's call it x, because that's what it is. All times the height we know is 18. Okay, so let's shuffle some stuff around because multiplication, properties of multiplication tell me I can. So we have 1/3 times 18 times pi times x squared. Okay, so 1/3 times 18, or 18 divided by 3, is simply 6. So we have 216 pi is equal to 6 pi times x squared. Put the x squared in parentheses. So now in order to get the x squared alone, we're going to divide by 6 pi on both sides. Divide by 6 pi. We get 216 divided by 6, 206, pi's cancel. So then 216 divided by 6 is 36, is all equal to x squared. So then you take the square root in order to undo the power of 2. So the square root of 36 would be 6, and we're in the unit of inches. So my answer for x is 6 inches, or that is my radius. And that is all that I have for you today, folks. So I want to thank you for taking good notes, and I shall see you soon.